Hello. Oh, cool. We are live. And my microphone is on. Awesome. Uh, yesterday, yesterday I did stream. If you're following the YouTube videos, you may notice that there was a gap in my streams, and I did stream. However, it was kind of a disaster. Um, I mean, not that my streams are ever like anything like perfectly executed masterpieces of streaming or online education or rhetoric or lecturing or whatever. But it was not a great stream for the first 20 minutes or so. My microphone was off. Uh, I spent a great deal of time working on. Um, I'll show you what I was working on. Let me pull that up. So I wanted to start adding a laser power up. So let me just actually, let's wait until the game starts first. I want to start adding a laser power up. So modify code data. Just happen to know off the top of my head that's the number for giving you a laser. And I did, and you've got a laser power up. But underlying some of the implementation was this assumption that laser shots would disappear in the order in which you fire them, which is true in this case, because you fire it, it goes from bottom to top. If you fire something after that, it's going to hit the top after that. Of course, I realized when it came time for me to start thinking about how I was going to do collision detection, the thought occurred to me, wait a second, if the lasers can collide with objects and you can move around from left to right while firing your laser, you could have a situation where you fire a laser, move to the right, fire another laser. The first laser hits a brick, the second laser keeps going. So that assumption is not true. So there's just a bunch of time wasted on that. So, like I said, kind of a disaster stream. The reason for doing that assumption is that we are programming Game Boy game in assembly language. We don't have access to or the processing power for libraries that can deal with arrays or even linked lists particularly well. I could do this with a linked list actually, but I won't. I mean, I could only kind of do it with a linked list. Anyway, it's not important. What is important is, like, we don't have dynamic memory allocation, is what I mean. So I could do it with a linked list, but it would still be using statically allocated, a pre-allocated array of underlying laser shots. But not important. What is important is that because we don't have access to that, I was using a technique which is called a ring buffer, I guess. I believe that's what you'd call it. Where the idea is that you've got an index variable which starts at 0 and as you fire shots moves forwards up until it reaches the max number of shots and then it loops back around. And so we can just keep writing to, whenever we fire a shot, we can write to whatever index of the array is pointed to by that index variable. And so what happens is after you fire the fourth shot, it's going to be pointing at 0. And then we're also keeping track of the number of shots fired. As soon as the number of shots fired goes down below 4, you can start writing again at that 0 position the new shot. So that was why the technique that it was being used, and that is a useful technique in certain cases, just not in this case, because we need to have this sort of dynamic ability to remove shots in action in any particular order. So there's the question of how are we going to do that? Oh, you know what? I'm sorry. I made tea. that is currently sitting waiting for me. So I'm going to go drink that tea. Be right back. Well, I'm not going to go drink the tea. I'm going to go pick the tea up and drink it on stream. Anyways. I was worried that the tea would be cold or unbearably pungent. It's Earl Grey, and it had been steeping for a long time. It's not cold. Oh gosh. Okay. So, what next? What shall we do? Oh man, that tea. It's pungent, but I like it. So what are we gonna do? Um, there's a bunch of approaches we could take. Um, instead of the ring buffer, to keep track of like which laser slots we can use, we could do what I mean. If I had a real programming language, like if I were using Python, actually, Python's a great example because you basically never use a linked list in Python. Because I could use a linked list, and that maybe is what I do if I were using Java or something like that. Like Java or linked lists are really good for when you are iterating through a list of objects, or or removing objects and adding objects a lot to the list. So a linked list might be what I do in Java, at least in terms of the reality is these days you should just use an array for most things, like a vector type or whatever you want to call it, because the occasional resize is no big deal, and you get really good cache coherency because everything is packed together. Which is not something you get with a linked list, but anyways. That was rambly. The point is I could use some sort of array type where I just have in the array or list type, or where I have in the array the laser shots that I am dealing with, and I remove things, laser shots, once they disappear, and then I have to pack the list down, shuffle everything over to the left when I remove something. That's not what I'm going to do. Like performance isn't really an issue here, even on the Game Boy, because the number of shots in play is so small. It's like, I think I decided for gameplay purposes I wanted only 4 shots, but it could very easily have 8 shots, and it's still like, it wouldn't be a big deal to shuffle 7 array elements over every time a shot is destroyed or whatever. But the actual reason I don't want to do that is because the code for that is going to be just bulkier than I'd like unnecessarily bulky. So I don't really want to do that. The other thing I could do, and as I talk, I sort of feel myself feeling as though I should do it this way, but I don't think I will either, is the thing that I said about using a linked list. And the linked list will just be the backbone. Although I'm not sure if the linked list will totally help what I need to do. No, the linked list wouldn't. Like, it would help me remove things, and it would help me iterate through things. Like, it would help me remove things well enough. The idea is that I'd maintain the 4 slots, and I'd just maintain a list of, I don't know. Never mind. The linked list is a dumb idea. Let me not a dumb idea, but I'm not going to do it. It's kind of a dumb idea. No, what I'm instead going to do is I'm going to maintain a variable, just a bit mask, indicating which slots are occupied. And then use that to determine which slots are free. It's not the fastest thing in the world, but it's like very like memory usage. It's a single byte, and it's easy. It's easy. It's straightforward. It's I guess the sort of thing that you do when you're Game Boy programming. Game Boy is good at like good-ish at dealing with the bits in a byte, so to speak. There'll still be some annoying iteration to find a free slot, but again, we're talking about at most 4 to 8. I think 4 is what we're going to do. So the iteration cost is negligible. So let's see, what are we going to do now? I also want to mention just very briefly, before the stream, I knocked a couple of things off of my to-do list. I consolidated the sprite data. So now all of the sprite data, except for the ball because it goes in a different spot, is in one big chunk, and I just load it all at once instead of having. I used to have a load laser sprite, load particle sprite, load flash sprite, and now I'm just doing it all at once, which is just a little bit cleaner and faster and easier. If I want to add a new sprite at any point, I just add it in right over here, easy. Then the other thing I did is I moved the particle code, the flash code for when you like hit a brick and it flashes because you can't destroy it just yet or at all, and the nascent laser code into their own modules. They were all that stuff was packed into game.asm, which was getting kind of unwieldy. It was like over 500 lines of code. It's already unwieldy, so it was ridiculous, honestly. So do we use paddle at any point? The paddle include? Can I get rid of that? I think I can get rid of that. Can I get rid of ball? Can I use the ball code constants? I think I might be able to get rid of the ball constants too. Let me see. Yes, awesome. Okay, so I did that to make game.asm a little less unwieldy, and that's actually going to make working on the laser code a lot more pleasant. Because I'm not going to be scrolling through game.asm constantly. So, cool. That is probably more than enough preamble. Let's get to fixing the lasers, and then if I can't stream for too long because I have a gym appointment at 4. So I probably am just going to fix the lasers and call it a day for now. I actually talked about just doing the laser fixing off stream, but I just have like a bad hair day. I have a lot of my receding hairline shit. Oh, sorry. I shouldn't swear on Twitch or YouTube or anywhere. Swearing's bad. But I talked about doing this laser stuff off stream, but actually I think it's a good exercise. So basically the difference is we're getting rid of this next laser variable. I might keep it eventually. I might actually keep it. I might keep it, but I'm gonna keep it just for temporary storage. What we actually want is I can definitely get rid of this next laser mask, though. And I can get rid of laser off screen. What I actually want to do is have an active lasers variable. Oh, also, I did some research, and I've discovered keystrokes for column selection, which means that I'll need to go into my edit menu and a whole lot less. So from here, what are we doing? We are... This all stays the same. This all stays the same. Active lasers will get cleared out. I'm not going to bother initializing X laser, even if I keep it. I think I'm going to need it, but and I am going to, yeah, I'm going to keep doing what I'm doing here. So none of these need to change either. Like I am just going to keep using the OAM slots and putting the lasers off screen even if they're inactive. So that doesn't need to change. What's going to need to change is going to be fire laser and update lasers. Let's start with fire laser. This all stays the same. We check to see how many lasers are currently active, and we return if it's already at max. And what I'm actually going to do, yeah, this is exactly what I'm doing. I'm going to be called find next laser. I'm just going to have this routine called find next laser. And all it's going to do is load a active lasers, load HL next laser, sorry. All this is going to do is iterate through the lasers to find a free slot. That's the basic idea here. So we get active lasers, and we're going to, I'm going to need to, I'll do that in a separate method, or separate function. Procedure, sorry. Functions return stuff, procedures don't. That's the difference. So we're just going to iterate through this. And to do that, all we do is we, okay, first I'm going to actually load into HL0. We're going to start with 0. We're going to see if, what's the fastest way to detect if the lowest bit is set? Probably doing a rotate. Rotate right. And now I have to determine, I think to make this easiest, I'm going to say the rightmost bit corresponds to 0, so I'm going to rotate right. And what that's going to do is that's going to take the bottom bit and it's going to put it into the, it's going to rotate the bit. So the bottom bit becomes the top bit becomes this bit that's second from the top all the way around. But what this also does is it's going to, let me actually double check the reference. New window. Let me double check. Z80. I believe this does the right thing. The carry becomes the value of the right. That's what I thought. So there's two variations of this instruction. There's RRA and RRCA, and I just wanted to make sure I have the right one. This is going to put the bottom bit into the carry flag. So what we do is we return carry if carry is set. Wait, is that what we do? No, that's not what we do. I take it back. We return if carry is not set, because that means that the slot is free. Otherwise, we're going to increment HL. And I'm just going to jump back to loop. And I'm going to assume because we're doing this check for max lasers, that we will eventually we're going to find a free slot. So this is just going to keep incrementing next laser until we find a free slot. At which point next laser is going to contain the thing that we want to do, that we want to fire, and we're golden. So then at that point, all of this stays the same. This is where we're just setting up the next laser. But this is going to change. Previously, this is where we did that ring buffer thing to increment the index around. Increment the index and then loop it around back to the beginning of the slots. And instead, I'm just going to put this in a separate procedure, and it's going to be called like mark next laser. And all this is going to do is this is going to set in active lasers the fact that next laser is the laser indicated by next laser is now in use. And it's unfortunate. The Game Boy CPU has a it has a bit manipulation instruction called like set, which, if you did this would set the 4th bit in A, which is basically what I want to do. But unfortunately, there is no way to specify this as like a variable of any kind. To my knowledge, I'm like 99% sure that's the case. Yeah, there is no, right. So instead what I'm gonna need to do is load A with 1. Let me load B with 1. Load A with the value of next laser. And we just have to manually do an iteration. We're going to construct a mask in B and then apply it. So to do that, we just say, well, is next laser 0? Sorry. Yeah, we'd say is next laser 0. If it is, then we're done. Otherwise, we are going to, I guess there's no, this sucks either way. Otherwise, I'm going to shift B to the left, decrement, and decrement A, and then jump to loop. So suppose next laser was 0 from the jump, then B is going to equal 1. We do this test to see if A equals 0. It does, we're done. Otherwise, if we suppose next laser equals 1, we'll do this test. The test will fail. This is going to get shifted to the left by 1, so this is then going to equal 2. Then we decrement A, that's going to be 0. We're going to loop again back, and then we're done. I could actually make this a little bit faster, huh? Let me do that. I believe this should work. We just do the test initially. So at that point, we've got in B this mask that we want to use. I'm going to go get active lasers. I'm going to go put active lasers into HL. I'm going to What's the fastest way to do this? Probably not. Or do you load a... So we just get the value of active lasers, put it into A, apply the mask, write it back. Nice and easy. And that should do it. That should be it for Mark Next Laser. And I believe this will work. So, what is next? Hi, it's going well. How are you? Thank you for tuning in. Let me know if you have any questions or anything like that while I hammer away on this. So we can get rid of this laser off-screen check that I was doing. I might just try to rewrite this, honestly, because a lot is going to change here. Cool. So what we're doing here is we're just iterating through the lasers, but what we're also doing is keeping track of we're going to get the list of active lasers, and I'm going to put that into C for now, I think. This is one of those rare times when we're going to need to have a bunch of registers going all at once. So what we're going to do is we're going to check to see if this laser is currently active, just by testing bit 0 of C. And if it's 0, then that laser is not active, and we're just going to jump to next. And in next, what we're going to do is we are going to shift C to the right. Have I been shifting in the right direction? I'm pretty sure I've been shifting in the right direction. This may require some debugging because I may have made a mistake somewhere, but for now, I'm pretty sure we shift C to the right. That's what we want to do. And then we're going to, of course, decrement B and jump back to the beginning of the loop. A lot of comment here, actually. Check to see if this laser is active. I'm going to put this comment off to the side. We're just going to say use active laser mask down. Like whenever I've got, like it's hard to know that C here corresponds to active lasers in isolation. So I think comments are really good for things like that. So then having done that, what are we also going to want to do? So we have in HL, so right, and we're also going to want to probably increment L here to move to the next laser. And then we're going to want to update the laser. Sorry, not add to, sub to, write it back, but then we're also going to want to check to see if it's gone off screen. I was doing this math here to check for it. Right. Yeah, and this I hate this math, but I'm going to just keep it because that's the easiest thing to do. All this I'll delete, actually. Check to see it. So So this is now going to be update laser position. Check to see if this laser is now off screen. You know what I can actually do? I should actually be able to get rid of this laser count. I'm going to get rid of laser count, so I don't need to worry about it. And then where I was checking laser count, fire laser, I'm going to replace this with, we're just going to check to see if all the lasers have been fired, which is easy enough to generate. We just are going to make a mask. Right, so if that was 4, this is going to be 3, which in binary is going to be, oh no, this is not what I want, sorry. I'm actually just going to write it in like that. So we just check to see if these are all full. And that way we don't need to have a separate laser count variable, which is going to make my life easier. It made the firing easier, and it's going to make the updating easier. Check to see if this laser is now off screen. I should have another jump here. Oh God, and now I'm going to need to actually think about it. So we're checking to see if it is between the bottom of the screen and just off the top of the screen. I'll figure out which condition I need in a second. Now I can get rid of this thing where increment laser count. And then all I need to do is mark it as inactive. If it is. What's the easiest way to mark it as inactive? There isn't a super easy way. That reads nicely, so I'll do this. I'll keep track of the laser that I'm firing in B instead of counting down, which is a little bit slower. Because I can't just rely on the fact that decrement, and I have to move it into A. I can't just rely on the fact that decrement will set the appropriate flag, but this way, in B, I'll have the currently firing laser number. So that makes it easier. I mean, I basically need to do the opposite of mark next laser. And even though it's a little bit slower for the sake of symmetry, I'm going to call it clear next laser. And actually what I could do is I could just maybe I hate calling conventions. This is, I guess, an idiosyncrasy of my assembly language coding styles. I don't like saying, oh, this procedure takes A to contain the laser to be marked, which is what I'm doing right here. But I'm going to do it. Because there's no point in having this right into next laser just for the sake of symmetry. So, fire laser. A. So yeah, yeah. Well, that's true, but also I want to make sure that I understand my code. And the sloppier I am about things like coding conventions, the less likely that's going to happen. So I try to be, oh, hey, Nelly. Oh. Nelly, say hello. I have to be very careful about how I point my camera because I am just here in my boxers because quarantine, baby. But I do want to make sure Nelly's face gets on camera. A good cat. Hell yeah, cat stream. Hey Tom. Nelly's the real star. The assembly language programming is just a sideshow. Load A with B, call Mark Laser. And then the only other thing is that, sorry, not Mark Laser, Clear Laser. The only other thing is that unfortunately, this uses B, and so I gotta make sure that I preserve B. BC. Nelly, oh my gosh, you are perfect. Load A with B, clear laser. Now actually I have to write clear laser, but clear laser is basically going to be the same as mark laser, just sort of in reverse. And what I mean by that is instead of loading B with 1, we're going to load it with not 1. I don't know. I hope the assembler supports this syntax. So this means that it's gonna set every flag except for every bit except for the 1 bit. And I guess and the other thing I'm gonna want to do is I'm gonna want to rotate left instead of shift left. So that way we preserve that. So this just means that we're going to have every flag except for every bit except for the bit that we want to clear is going to be set to 1, and then we're going to AND instead of OR it. So because in the bit mask, the bit is going to be cleared, this AND is going to guarantee to clear that bit, and then we'll just write it back. I think that should do it. That's about the limits of how complicated I ever want my code to be. And then it doesn't matter that we haven't updated C here because we're just immediately going to C storing the bit mask because we're immediately trashing the bit that we just cleared. And then the only other thing is I gotta remember how this logic works because I apparently deleted the condition. So basically, if A right now is greater than the variable in here, then we're fine. We don't want to do this. So if it's greater, that means that we are going to jump when there is no carry. I think that's right. This, I think, is right. Famous last words. I deleted. Where is this? An update laser's done. I need. Oh, I called it next and not done. Apparently I use both laser count and laser off screen still, somehow. Where do I use laser count? Oh, I clear it out. Don't need to do that anymore. And laser off screen. Oh, I'm just going to set this to -16 now. And that should do it. Now let's find out how well this worked. I'm going to need to give myself a laser. Modify, I'm going to set that to 2. Just hit run. Oh, it definitely didn't work because I can't move left and right now. Things are just going crazy. So clearly something terrible has happened. Awesome. Awesome. Cool. So that did not work. There is some kind of bug going on. Let me go take a look at active lasers. Active lasers is cleared. That's what I like to see. Let me go to update lasers and set a breakpoint here. Why is there no menu item to do that? I hit run. Let's see how this goes. Right, bit 0 is set, so we just go to the next one. So this, I can't see why this is keeping my inputs from working, but apparently it is. Oh, that's because I forgot to return. So the code was just, oh dear. Okay. Yeah. Love assembly language programming. The code was just it was just running on into the next procedure. Let me get rid of that breakpoint, see if that improves things. And well, now firing doesn't work, which is sad. But so let me first of all go to active lasers. Sorry, let me go here into active lasers and see if it's not terribly corrupted, so that's good. So let me go to fire laser. And hit run and try firing. Oh, of course. I don't have the laser power up because I reset. That was the problem. Let me just hit run and see how well that works. Oh, shoot. That seemed to work okay, so let me just try it. No, it does not work properly. At all. I mean, it works mostly okay, just not completely okay. Why isn't it working properly? Like if I fire the laser and just let it go off screen, it works okay. If I fire 2 lasers, whoops, game over. I guess I need to clear that stuff out too, huh? Oh, I gotta give myself the power up again. Modify 2. Things are definitely going. Something's going real wrong here because also the particles are flying all over the place. Let me take a look. Oh, jeez. What is happening here? Ugh. Annoying. This all looks. Oh, am I? Oh, I bet in clear laser. Right, that checks out. I'm corrupting HL. That's the problem. So I also gotta. Push and pop HL. Whoops. I have to. I think this is going to fix that. I was corrupting HL inside clear laser. And that would explain basically everything that we saw. Sorry. Make sure to clear game after game over. Because we saw that, right? When I got the game over and started the new game, all the sprites were in the wrong position. So let me make sure to fix that. Oh, also, alright, that I also need to fix. But this is still not quite right. What am I missing here? Yeah, it's not quite right yet. Oops. Like, what's happening there? If I go to active lasers, I suspect it's going to be, yeah, it's 0. We are somehow I'm sure this is just a problem with me. I'm sure this is just a problem with me setting the mask. The lasers are supposed to destroy the bricks. They don't yet. I mean, they're supposed to eventually. Right now, they don't do anything yet. An interesting idea to make them bounce the ball. I've never seen that before in a breakout game. I wonder if that would make it too easy. But it's kind of a neat idea. I'm sure the problem is that I am somehow messing up my active lasers mask. Oh no, I'm running low on time and I screwed up. Let me go to clear laser. I screwed up and didn't think to eat properly, so I'm all... I feel confident in this right here. And I feel confident in this right here. I think maybe this is wrong. Is this wrong? What do we do? Suppose active lasers is 0. That's an A. Next laser is set to 0. We go off the right. We're just returning the new value in the next laser. So it'll be 0, and then we go off the right, and if it's not 0, we keep going. No, actually, I feel good about that too. So then the final test is C is shift right, logical. I don't know, this all feels really good to me. Obviously there's some kind of bug. I think the bug has to be, let me go look and update lasers. Let me go for the case where we clear the laser, which is over here. Okay, so what's B here? B is 0, cool. Go clear laser, load B, F0, and A, 0, so we're just going to say we're done. Load HL's active lasers, we and it out, we write it back. That is good and makes sense. Now I'm going to like fire 3 lasers. Clear laser. Yeah, so that all is fine, and we clear the laser out, and then pop HL, pop BC, shift right logical, yeah, okay, increment L, increment B, we move on to the next laser. Did that work okay? Okay, so now we're going to clear this. FC. Let me open up my calculator. Calculator. We're going to go into byte mode. We're going to type in hex FC. Yeah, that's not. That is what's wrong. That's the bug. I used the wrong instruction. I want to see. So this was putting the value of the carry flag into the rightmost bit of B. If you do just RL, RL sort of does a 9-bit rotation using the carry flag, and that is the problem. Or a problem anyways. That was a niche enough bug that I feel like that's probably the bug. And it because it required digging really hard. You get to the point where you have to dig that hard, you've probably fixed all the other bugs. So because of that, it was corrupting the mask and messing everything up. So let me go check to see if that fixed it. Using the RLC instruction does just an 8-bit rotate. Whew. Run. Yeah, that feels correct. There we go. Cool. Did it. Done. Thank goodness, because I am super hungry and need to go to the gym in a moment. So, could not stream for a moment longer. Add to-dos. Thank you. Yeah, man, what an annoying bug. I hate the names of those rotate instructions because it's like it's so not clear that RLC means rotate without carry and RL means rotate using carry. But git commit, move unneeded imports. Whew. And then finally, yes. Yay game. Tell me about it. So tomorrow we're going to make those lasers actually blow up the bricks through collision detection. But for now, this has been A success, a complete success. I can't. What's the Portal song? How does that go? This has been a success. Lasers. There we go. Awesome. All right, I have to run. Thank you so much for watching, guys. Take it easy. Have a good day. Well, why do they always need cryptic names? Yeah, tradition. Um, Back in the day, things were very limited. Like on the 6502, all of the instructions are exactly 3 characters long by design, so that way things are very regular. And I kind of like that. And it's usually not a problem. Like, I appreciate not needing to type load every single time or return every single time. But then sometimes it's stuff like RRCA, and it's just not great design. Anyways, or like, God, some of the modern x86 like SIMD instructions have like 8 characters, and they're just completely unintelligible. It's ridiculous. Anyways, yeah, sorry, gotta run. Thank you so much for tuning in. I will be back tomorrow. I'm out.